All right, went ahead and click record. So we're going. This is chapter 15, working with interfaces and generics. In this session, we're just going to focus on interfaces, and we're really just going to focus on the code of common interfaces. So really, what is today? We're going to talk about what is an interface and why they exist, and then we're going to look at common interfaces and their implementation, how to work with them. And so yesterday we really dove down into abstract classes and abstract methods, whereas an abstract class, if we just quickly review that, an abstract class is a class that exists for the purpose of inheritance. Like, you cannot instantiate an abstract class. The whole purpose is to provide members to other classes. And so by marking a class as abstract, you kind of create this template, if you will, for child classes to inherit from an abstract class. Abstract methods can have abstract classes can have regular methods in them and regular properties in them, but they can also have abstract methods. So abstract classes can have regular methods, or they can have abstract methods. If we remember from yesterday what an abstract method is basically a method header with no method body. And so you basically say, by defining a method as abstract, you're basically saying, hey, any child class that inherits from this parent class must implement this behavior. And so it's essentially a contract by making a method abstract that says, hey, anybody that inherits from this class must implement this behavior. Because when a method is marked as abstract, there's no method body. And so that's what it forces the child to do. If you apply just one more layer of abstraction, that's where you wind up on an interface. An interface is only abstract methods, right? So if we think of an abstract class can have regular methods and abstract methods. It can have both. Well, an interface is only abstract methods. And so really, what is an interface? An interface is a contract or a guarantee that a child class enforces some behavior. So it's basically saying by a child class, what they say is implementing an interface. Anytime a child class implements an interface, that child class has to implement a method. And you have to basically, code a method that guarantees that child class has a behavior. And so in C#, there's a bunch of built-in interfaces. And they serve some very common purposes, and that's what we're going to look at today. We're going to look at some common interfaces and, why do they exist? What are the benefits of implementing an interface? But you can also make your own interface. So there's a bunch of interfaces built into C# that we'll cover today, but there's also, you can also make your own interfaces as well. So that's the gist behind an interface. An interface is just a bunch of abstract methods. Okay, and there can be some other things in an interface, but for the most part, an interface, I think of it as a bunch of abstract methods. If you want to create an interface, again, there are built-in interfaces off of add, new item, and I believe there's an interface option here, but if not, yeah, there it is. The naming convention for an interface is, you start it with a capital I. Anytime you see a class with a capital I, and one that Icomparable. It's kind of like this. The first two letters are capitalized. The I represents the interface, and then what it is comes after that. So that's the convention of the interface. I have a the PowerPoint pulled up here, and they, just to demonstrate this, they have an interface, and I can code this up real quick, called iDisplayable. And so just to, kind of show you what an interface, if I put this in my code, basically you create it like as such, and instead of Icomparable, they call it iDisplayable, A-B-L-E. And you can see it looks very similar to a class, except instead of the word class, it's the word interface. And again, you typically mark it as public. And then what you typically have in an interface are abstract methods. You cannot have a method that's not abstract. You have to have abstract methods. And so here, like if you notice, what are we looking at? We're looking at a method. It's a method. You could tell it's a method because it's got parentheses. But there is no method body. Like if you look after the parentheses here, you just got a semicolon. So it's an abstract method. All right. So the interface at this point, this is creating your own interface. I would say most of the time, at least from when I've seen interfaces and been useful, more often you're just implementing an interface that already exists versus making your own, but just to show you how to make your own. This is what this is. And again, it's pretty simple. String, and the method is called get display text. It takes in one parameter. I'm not even sure what SEP is, but what you're looking at here is an abstract method. There's no method body, and so you're probably going, what are we talking about here? Well, we have created this interface that says, okay, now when I'm making my own custom class, if that class implements this interface, it's going to require that class to write this method, is the short version of it. It's a way of enforcing a behavior on a class. And I think if I go ahead and demonstrate that, like if I have a custom class, and so often in our class, what is the thing? This is my coffee mug class. Now the way this is done is, like if I just, by the way, look at how many interfaces there are. A lot of interfaces, but if I type in iDisplayable, you say, well, isn't that how inheritance works? Typically what you're going to do is, remember, here's the rule of thumb, you can inherit from one parent, right? But you can implement many interfaces. And so typically what you have, if you have a parent, you inherit from that parent first, and then you comma separate. So like if coffee mug inherits from another class, let's just call it product. So here's our class called product, and product has a name, string name, okay, and we could say that our coffee mug is a product that implements iDisplayable. So that's how you do. The parent, it comes first after the colon, and then all the implemented interfaces come after comma separated. Okay, and this is actually pretty common, and I kind of showed this the other day. When you start digging down, if you hold control, you can click on the form class just to demonstrate, this form inherits from container control. Notice that there are no interfaces here, but if I click on this, Now you'll notice container control inherits from scrollable control, but implements this interface. Okay, so that's the syntax for inheritance. Basically defining this as the parent. And keep in mind, your parent can give you properties and it can give you methods and all this stuff, but the interface makes you implement a behavior. And so you might be going, well, why do I got the red squiggly here? And you can kind of hover over this and it says coffee mug does not implement the interface get display text. And so I don't even, what is get display text supposed to do? Like, what is the purpose of this method? Like, it might help if we define what is this method. If I show potential fixes, it actually is pretty savvy and lets you implement the interface. What does this do? It gives us our method header and a method body, and then it basically, tells us to go ahead and return a string and accept a string. So if get display text, I don't know what SEP is supposed to represent, but let's just assumedly we're going to return some sort of string that says yep set. I guess what I'm saying here is I don't really know exactly what get display text is supposed to do. I know it takes in some string and it returns a string. So I took in this set string and I return this string. That's not the important part right now. The important part is that I showed you what is an interface. Okay, an interface is a collection of abstract methods. Why do they exist? Well, when you implement an interface, it makes you define a behavior of your class that's considered common. So I showed you how to create it. I showed you how to implement it. I showed you how to implement the interface here, as well as implement the abstract method. Like it's really not that hard, but I think a better demonstration of this, instead of creating my own interface, more commonly is like, hey, here's a bunch of common interfaces built into .NET that add some pretty neat features to your classes. And so I think a little bit more like where you're going to see the usefulness of this. You're going to see the usefulness of this when you start implementing interfaces that are already built into C#. So let's look at that. So if you don't inherit from a parent, like notice here, this just implements iDisplayable. So the language around this, they say that you inherit from a parent, but you implement interfaces. Okay, that's just the language. You inherit from one parent. However, you can implement multiple interfaces, but if you, in this case, they're not inheriting from a parent, they're just implementing the interface. Remember, if you do inherit from the parent, you got to put the parent first, and then the interface is after commas. And you'll notice this is the override of that getDisplayText method that was the abstract method. And this method returns a string. It returns a string with properties and data out of the class. So that's cool. So then, then you can use this method on your products. In this case, I could use this method on my coffee mugs. If I were to go into my form, just to tie it all in together. Not that this is all that useful, but it demonstrates it. Right, so this is, what would we need to do? We'd need to create a coffee mug instance. And now I could say in my label, let's call my mug dot get display text, because get display text, and it does accept a string. So keep in mind, looking at the method header, it accepts a string and returns a string. Since it returns a string, we could put that return value into a label. And so get display text will be whatever I put inside of here. And so I said, yep. And then I'll say, nope, whatever. So my label will say, yep, nope. Again, I'm not showing usefulness. I'm showing how it works. Full circle. How to get interfaces to work. Okay. More so, I like to look at the common interfaces in .NET, and I think that by knowing these common interfaces, you can add some useful behaviors to your classes. And so when we're creating these classes, what am I talking about? Well, Coffee Mug is our class. And so what useful behaviors have we learned so far? Well, there's some things that we inherit, like toString, public, override, toString. Like we learned about these methods. And these methods are pretty common to implement these methods. And where do these come from? These come from inheritance, right? They come from the object class. And so in a previous lecture, I showed you kind of how to put these methods into your class, because they add some functionality to your class. And this is really, we're doing the same thing here. We're implementing interfaces to add functionality to our class. Is this making sense so far? Cloudy as mud, or clear as mud, clear as mud. Clear as mud. I think the last sentence, I'm going to try and say it again. Interfaces allow you to add functionality to your classes. And so we get certain functions out of a class, just by adding properties and methods, and a class becomes useful by adding these things. And then we started adding like a toString method, and we kind of saw the benefit of a toString method. And then public override equals. And we kind of learned, hey, if I have 2 coffee mugs and I want to see if those coffee mugs are equal, then I can add in this equals method, and then when someone is using the coffee mug class, when they create coffee mug objects, now they could say, does coffee mug 1 equal coffee mug 2? And there's a way of determining that. Like, how do you determine if coffee mugs are equal? Point is, if you implement this method, now this class is more useful. If you implement this method, this class is more useful. And so by implementing interfaces, the class becomes more useful. All right, so I'll keep the iDisplayable, and let's just look at this first one, iClonable. You might be able to guess what iClonable does. You want to clone an object? Like you want to make a new object that has the same values of a current object. So in other words, I want to have a new coffee mug that starts with the same values of a current coffee mug. So let's implement iClonable. Well, how do we start doing that? Well, we know to implement an interface, you do this. You put it with a comma. So again, we're now adding the functionality to our thing to make it clonable, to make another thing with the same values. Well, I guess if you're going to have a coffee mug, well, coffee mug is a product, and we know that product has names. Maybe coffee mugs have... I got a coffee mug right in front of me. Logos? Is that what you said?
Handles.
Handles. Yeah, let's do handle. Sure, handle. Prop. I'll do handle style, a string. Handle style, right? So you got some, like, I don't know, this handle has some extra tabs, right? And there's a handle style. You got simple, fancy, whatever your handle styles may be. Point is, not super important, but this is a unique property to my coffee mug. Okay. So let's also say a coffee mug has a ounces, number of ounces that it holds, size, right? So we'll do prop int ounces ounce capacity. You with me there? Ounce capacity. Does that make sense? Ounce. So we have two properties that are unique to coffee mugs. And when I clone my coffee mug, I'm just going to make sure it has the same handle style and the same ounce capacity. Pretty simple concept. Hover over the interface and it says, hey, coffee mug does not implement the clone method. So if I dig into this interface, again, holding down Alt, let's see, hold down Control, excuse me, I can click on Iclonable and see a summary. Creates a new object that is a copy of the current instance. We're creating a copy. So here's our public interface called Iclonable. This is an attribute. We haven't talked about those. And here's our method. This is our abstract method. This abstract method has no parameters. It returns an object. Now, the other day we learned that anything could be passed into an object. Object is the parent of all classes. So the method signature is a pretty simple one in that there's no parameters and it returns an object. Now, because any class that we create is an object, we can essentially pass anything into that return data type. Does that make sense? You can pass anything into an object. So it just has to return an object and no parameters. So let's go back to coffee mug. Let's implement this interface, show potential fixes, implement interface. There it is, public object clone. Well, what are we going to return? We can actually, because a coffee mug is an object, remember yesterday we learned about that weird casting where you can do, remember this one, where you can say, and I'll code it right here, object parent equals new coffee mug. Remember this yesterday? And we were like, we've never seen this before, and what does this really mean, and how does this really work? Well, because a coffee mug is an object, that's an implied automatic inheritance. Everything inherits from object. You can pass a coffee mug into an object. That's why this works. That's why the return data type can be coffee mug. Okay, so essentially we need to return a coffee mug. And so, yes, sir.
If you do new coffee or object equals new coffee mug, doesn't that mean that you won't get the coffee mug's like special like properties and methods?
Yeah, but luckily we don't have to. Because you're correct. But luckily we don't have to do that here. You're right about that. So how does this method look? So we know we need to return a coffee mug, right? And so what you can do, mug.handleStyle, you create this new object. Oops. Mug.handleStyle. handle style equals this handle style. So there's basically two coffee mugs here, right? There's the new coffee mug. There's the new coffee mug. And the instance coffee mug. So you have to keep in mind when you call this clone, you're going to be calling it from an instance variable. So when I say this, I'm referring to the instance coffee mug. And so you'll see that when I actually call the method here. So there's two mugs here. There's mug 1 and mug 2. Okay, and I'll step through this so you can see it. But then we'll say mug dot name, because keep in mind products have names. So coffee mugs have names. And I'll say mug dot ounce capacity equals this got ounce capacity. So what are we doing? We're copying. We're making a new object. We're setting that object's properties equal to the properties of the instance coffee mug. Instance coffee mug. Okay. Not my point. Not the point here. And then what do? We return the mug. Do you notice there's actually something quite interesting to me here? What's interesting to me here is that when you're defining a thing, you're defining the coffee mug. And let's just say when you're defining the equals method, you get to define how things are equal. Because when you're creating a thing, there is no way to define that all things are equal like one way. Like you have to say these things are equal when these conditions exist. Right? So you get to determine when things are equal. It's the same thing with this clone method. Okay, you're going to clone coffee mugs. What does that mean? You get to code it. You have to decide, hey, if I'm going to clone this thing, if I'm going to make a copy of this thing, what does that even do? What does that mean? And in this case, I'm just making a full copy of all the properties. I'm just saying all the properties go from the first thing to the second thing. And then return the mug. So now we've done this. We've implemented iClonable. You know what? It really didn't like something here. It didn't like that I changed this to coffee mug. It wants me to keep that as object. Now because coffee mug is an object, this still works. But you'll notice when I change that to coffee mug, that red squiggly came back. So it actually enforces that return data type, which is fine. Okay, did you see that? Did everyone see that change? I thought I could change this to coffee mug to show you specifically that I'm returning a coffee mug, but in fact you can see that I am returning a coffee mug. Because a mug is an object, this works.
Where do you make mug an object here?
Where do you make mug an object? It's automatic. So what happens here on product? And this is important, and I think this would confuse a lot of people in lab. What happens on product, even though you don't do this, it's implied.
Okay.
So because a product is an object, and a coffee mug is a product, there's your inheritance chain. So it just happens automatically.
So every time you create a new class, it's a child of an object.
Correct, 100% correct.
Even if it's a subclass, like way down.
Even if it's like 30 classes down, ultimately it's still as object as the super granddaddy class of them all. Okay, so all of this just to say, Now I've got coffee mug, my mug, and I can say coffee mug, your mug equals my mug dot clone. Now why is this going to bark at me? Creates a new object. The new object is cannot convert object. Ooh, interesting. Okay, so you know that clone returns an object. So we're saying child class equals parent class. We can do it the other way around, but you can't do it this way. So this makes you do a cast. Because clone returns an object, you have to cast it into a coffee mug. And we know, because we just got done coding it, that clone returns a mug, so we know that this cast is going to work. And what does that do? It sets my mug equal, we now have two objects. One's just a clone of the other. So if I were to say, name equals, I'm just looking at my coffee mug, and if I'm going to give a name, my coffee mug says the Friday Crew. That's what my mug says. If I'm going to give it a handle style, I'm going to say fancy. And if I'm going to give it a ounce capacity, I'm going to say 20 ounces. So here's an instance of a coffee mug. Because I implemented Iclonable, I now have this new feature of my class. And this new feature is to make a copy, or AKA a clone. Before I implemented the interface, I couldn't make a clone. Now I can make a clone. So it's just a fast way of making copies of objects. When it comes to data, you'll often have CRUD operations, right? Create, read, update, delete. And so when you're creating new things, oftentimes it helps to create objects from copies. You're working with data. Instead of starting with empty objects, you can start with copies, a bunch of copies of one another kind of thing. Anyways, so if I say, let's just plug this, let's finish this out. I want to do a toString. And my toString will return a string of the mug's name is name. It has a fancy handle. And supports this many ounces. So there's my coffee mug toString. The mug's name is that. It has that handle style and supports that many ounces. And so if I were to basically output your mug, label result.text equals your mug.toString. The idea is that it should get all the data from the copy, right? That's the idea. And you can see that the copy or the clone did in fact work. And if you want to see it, again, I think it helps to see the clone work. So I'm going to put a breakpoint in the clone, and I'm going to start debugging. And it's going to just hit right away because this is on the form1 constructor. So when the form is loading, it's building the form. There's no button click here. Notice it goes into the clone. We create a coffee mug object. Keep in mind, this mug called mug is full of empty fields, like null, null, and 0. The keyword this, that's our instance variable. Keep in mind, our instance variable comes from the instance my mug. So the keyword this is the instance variable, which is called right here, my mug, makes this my mug. Does that make sense? So if I'm looking at these, there's two mugs here. There's the new instance, then there's the what you would call the current instance. The current instance is always represented by the keyword this. Yep.
Basically on the right side is your current mug, and then you're setting it on the left side to what the new mug will be, the clone.
Yeah.
Okay.
Yeah. This is the current mug on the right and the new instance on the left.
That makes sense.
Yep. So this dot handle style is fancy. So I set the new mug's handle style to fancy. The current name is Friday Crew. So the new mug's name is Friday Crew. Ounce capacity, ounce capacity. Now the new instance has all the data copied over into it. It returns it and casts it. Remember, because this clone returns an object, which is a parent of coffee mug. So you can't say, coffee mug child equals parent on the right. Now you could do it the other way. The parent can be on the left, but the parent cannot be on the right. And because it can't, you have to cast it down. You have to cast it down into one of the children. The child is the coffee mug. And so that's a valid cast. We take this object and cast it down into a coffee mug here. I was trying to do the cast in the class, which was not the right place, and you saw my mistake. And then now I can call your mug to string, where it prints out that to string. Woo! All that for a copy. Right?
So I don't really understand the whole, why can't you just make a clone class? Or a clone method, because you did all of the coding that you would do.
Good question. The question is a really good question. Why do you need to implement the interface? Why can't you just make a clone method in the class, right? Really good question. So if I were to go back to coffee mug, I like this question. Why do I need to implement an iClonable? Can't I just make a clone method like this? Yes, you can. Yes, you can. You can make your own clone method. Why are we doing this interface? The answer to that is that standards. And what I mean by standards is if you make a clone method with one signature, I might make a different clone method with a different signature, and you might make a clone method with a different signature, and you might make a clone method with a different signature. And so there's no standardized way to understand, I've never seen this class before, whatever this new thing is. I've never seen it before, and I want to clone, but now I got to go study the documentation on how to clone because his clone's different than his clone, which is different than my clone. Right? By implementing the interface, it's going to force us all to write this clone method in a standardized way that has this method signature. And this method signature says there's no inputs and an output of object. See what I'm saying? And so as a user of all these different classes, all of you made different classes, and all of you, I'm coding using all of your classes. Right? Because that's really what .NET is. It's a collection of classes from developers all at Microsoft. Right? And I want a standardized way of understanding how a clone method should work. I don't want your class to have one kind of clone and your class to have, your clone has 3 inputs and 1 output. And and the output, your class is, I think I explained that. Did I explain that?
Yeah.
Cool. That's a really good question though. And so it's about standardization. It's like, hey, cloning is one thing, but look at all these other, look at these other things. Okay, and I'm going to pause the recording here. We're going to take a break, and we're going to get back, and I'm going to try and do a few of these other ones. Okay, and just be a few more demonstration of interfaces. All right, so we'll pause here. Okay, the next interface I want to show you is Icomparable. And let's talk about what that allows you to do. So since I'm in the demonstration of coffee mug, let's implement Icomparable. And interesting, Icomparable kind of comes with two interfaces. And we're going to talk about what a generic is tomorrow. But Icomparable comes with, there's Icomparable and Icomparable with the data type in these angle brackets. This is called a generic. This is the more updated version of the interface. So I'm actually just going to do the one with the generic. Okay, and so what does Icomparable allow you to do? Well, you might remember when we have an array of things, an array of objects that there's this fun little method called array.sort. You guys might remember array.sort. But the idea is that you can have an array of coffee mug right. So here I have an array of coffee mugs with two mugs, my mug and your mug, right? So and then we've got array.sort my mugs. Okay. What does it mean to sort coffee mugs? I don't know. What do you think? Do you sort them by name? Maybe you sort them by name. Maybe you sort them by the ounces. Maybe you sort them by whatever, right? That's what Icomparable does for us. Icomparable allows us to compare coffee mugs so that when we sort our coffee mugs, they know how to compare against one another. I think that's pretty useful, right? By a show of hands, how many of you remember using array.sort in this class? Most of the class, right? If you don't remember it, you just got to rewind back to the arrays chapter, and I'm pretty sure it was a part of the lab, right? So whether you remember it or not, I'm pretty sure it was built into our labs. So that's what Icomparable does. Icomparable allows us to compare our objects against each other. Therefore, when you sort them, it knows how to sort. Because right now, yeah, this compiles, but sort doesn't know how to sort coffee mugs. Like, I don't really know exactly what that would do, but presumably I'm going to assume it's not going to work. That's the whole purpose of this demonstration. And so for this, instead of cloning our coffee, well, let's add a third coffee mug just for the heck of it. Coffee mug, stranger mug equals new coffee mug. And the name of this is unknown mug. The handle style is broken. And the ounce capacity is 12. Okay. So now at least we've got a different mug, right? That's not the same, full of data. And our array of mugs will include stranger mug as well. So now we've got 3 mugs in our array, and we can sort them. How might you go about displaying these mugs on the screen? You're probably going to want to loop through your array, right? You're probably going to use a for loop and loop through the array of mymugs.length, label result.text. We have a toString plus equals mymugs sub I dot toString. You with me? So this is going to loop through all 3 mugs and print them into a label. Good so far? But what is the sorting really doing? Well, probably nothing. I'm going to assume that it's just going to print out my mug, your mug, and then stranger mug in that order, because if if it even runs. It might, yeah, there we go. It doesn't run. Why does it not run? Well, there you go. Wait a tick. It says it doesn't implement Icomparable. Let's get rid of this. But still, I don't think it's going to run. If I start without debugging, like it won't even start at this point. And presumably that is because it doesn't know how to do the erase sort. Now, like notice if I just comment out this code, I just want to get this thing running. Okay, it runs, right? But as soon as I bring in the erase sort, which is interesting that it compiles and it's not really giving me an error, but it's just also not launching. Like literally if I comment out this line, the thing launches. But as soon as I bring this line back, I'm kind of not a fan of this. This is interesting. Like it just doesn't launch. Interesting tidbit, not all that important, but now you know. So let's go ahead and implement Icomparable. And let's implement the generic version because we have at least been told that that's the newer version. It's the newer way. In fact, you know, I've watched a YouTube video where a guy kind of rants about it. He's like, look, you just need to get rid of the old way and just have the generic version. So let's see if we show potential fixes here. Notice there is Coffee Mug does not implement Icomparable compared to Coffee Mug. So let's click on Implement Interface. Before I do that, I'm just going to click on Icomparable and just kind of glance at what this looks like. This is how you create what's called a generic. It's kind of a weird thing. We'll talk about this generic stuff tomorrow. But this is how you would create a generic. So what we have here is an interface called Icomparable. And so it might be worth a quick read here. Summary: compares the current instance with another instance of the same type and returns a number that indicates whether the current instance precedes or follows or is in the same position in the sort. So basically it's going to return a negative number, -1, 0, or +1. And it's kind of like a -1 represents it should come before, a +1 means it should come after, and a 0 represents the same position. That's kind of the idea here, is that this method returns an int. Look at this method, it's called compare to. This method returns an int, -1, 0, or 1. -1 means that, hey, we got two objects, and the current instance, being this, should come before the another object. You know, basically there's two objects that you're comparing. Yeah, Josh.
Okay, so is it based on, like, if it's a string, it would be alphabetical. If it's a number,
You get to define it, but yeah, that's how it's normally gonna. That's how we will define it. Since we're gonna use, let's get into it. So let's show you that. Like, so let's now that we've looked at, again, you kind of control click and you can read about. Basically, this method returns an int. That int represents order. That integer represents order. Parameters, an object to compare with this instance. Okay, a value that indicates a relative order of the objects being compared. The return value has these meanings. Value meaning less than 0 should be, that's what I just explained. 0 is that, and greater than 0, it should follow. Okay, so that's kind of what so this return of an int has meaning. And that's how they're going to compare against one another. So that's kind of cool. So let's implement this interface. Again, this will be something that you do in your lab. So I click on implement the interface. And we get this. This is the method signature. And now keep in mind, we've got this other coffee mug. So we've got two things. We've got this dot coffee mug and we've got other dot coffee mug. We've got this, two coffee mugs. The first one is called this, and the other one's called other. And so we'll do something like if this dot, how do we want to sort our coffee mugs? We can sort it by name. Let's sort it by ounces because it's a number and that makes sense. If this ounce capacity is less than other ounce capacity, let's just assume they're equal. So when you say 0, the assumption is equal. You don't have to do that. You could just do this. If this is less than the other, like we're saying the instance, return -1. Else if this dot ounce capacity is greater than, return a +1. Return. Else, return 0. Okay, so all of our cases are hit. If else. Like one of these three things will be true. You know what I mean? One of these things will happen. 0 means equal. -1s means the instance is greater than the parameter. Keep in mind, the instance is greater than the parameter. This is the parameter. This would say the instance is greater than the parameter. And this, okay. So now that we've implemented compare to, the way this works is that the sort method calls compare to. The sort method calls compare to. We're no longer using return value. So kind of the thing that you just have to know, is if you were to look at this sort method, let's see if I can control click it. Good luck finding it. But presumably sort, okay. Array.sort somewhere in here, and I might have to, I don't know if my demo works, but maybe it's one of these overloaded ones, right? These are a bunch of overloaded sorts. But now this should no longer break, and actually, yeah, that should no longer break. Now if I bring this back, hey look, it's at least launching now. Remember it wasn't launching before? So now that I coded that compare to method, this launches, so that's great. Now I should be able to loop through them, and they should be sorted by ounce capacity. Now what's really interesting, we've got 20, this one's 20, and that one's 12. So I would expect the 12 to come first. If I wrote my method, compare to method correctly, and I guess I wrote it the other way. You could just reverse it, and so it's actually not doing what I would expect. And here, let's get in my coffee mug, toString. Here's a quick fix. Put a line break in your toString so that each coffee mug has a line break in it. And I just had these backwards. So now it should just get that. No, maybe I didn't. Maybe -1, return 1. Okay, interesting. Okay, here it is. This is working. I had it right the first time, but you know what I'm doing?
You're printing out the first one.
I am. Somewhere, I gotta comment out this right here. I still had something outside of the loop, okay? So my sort was working the first time. I didn't need to fix it. But notice the order is in ascending order by ounces because I have sorted my coffee mug by their ounces. We have sorted our thing.
How does it sort the other two? Are they just defaulted?
What great question. When they're equal, you basically don't change your order. Does that make sense? So when When one is greater than the other, you return -1. When the other one's greater than that one, you return 1. When they're equal, you return 0. And which basically means you don't have to change their order. Just as a demonstration, we'll make a 4th coffee mug. Just, not that you don't believe me, but let's do it. Coffee mug, student mug equals new coffee mug. Name is student mug. Handle style is also fancy. And the ounce capacity, students drink a lot of coffee, so we'll go 64. How about that? Okay, so the largest capacity should obviously sort to be last, yet we're going to add student mug as the first mug to our array. So it's going to have to, on our toString, it's going to sort it, and it should put that student mug last. And in fact, there you go.
What if you have 2 that are the same? Like, if you added another, 20?
Again, when they're the same, that doesn't change their order.
So would it just put the 20,
Like, if, let's put our cloned one, like my mug and your mug. So let's put them not next to each other, because I think that'll help you see it, right? So now that they're not added in the same order, they'll be right next to each other, right? So it just basically doesn't change it. It's just swapping places with one another. Is how that works. So then the question became, well, what if I didn't want to sort based on a number? Like, what if I wanted to sort based on alphanumeric, right? Well, there's actually already a built-in method to sort alphanumerically. So this is our test, right? This is testing the ounce capacity, and we're just going to test it differently. So what we're talking about is comparing strings. So we've got names. And this actually doesn't work because you can't compare strings this way. There is a compare to method. And so we would actually use compare to. Compare to compares the instance with the specified string and indicates whether the instance precedes, follows, or appears in the same order. So there's kind of a built-in way to compare strings. We would actually call this is string compare to, right? This compare to, we're saying we're comparing coffee mugs. This compared to says we're comparing strings. And so you would say if it's -1, return -1. I believe this is how we're going to do this. There might be a more succinct way to do it. But again, we're calling the built-in compare to method on strings. And it's the same kind of deal. This dot name dot compare to other dot name double equals a +1. I gotta get this right. Other dot name. So basically, if this compared to returns a -1, then we return a -1. Else if it returns a +1, return the 1. So you're just kind of using the built-in compare to. Else return 0. And now we're comparing our coffee mugs by the name. And so if we kind of go back to the form and we look at our coffee mugs, we got, again, this is going to be alphanumerically, so like T before U before S, that kind of thing. And so we should at least get the S, the T, and then the U. So now we're sorting by name. Part of, I find this really cool.
Can you go down and show? Okay, so do you have to send it through in a for loop for this to work?
So the sort puts it in order, and then the for loop just does the output. So that, just to demonstrate it, that's all that does for us.
Okay. I guess. Okay, so what I'm seeing is the array.sort is doing the compare to right now. So what's happening? Okay. Gotcha.
Yeah, the array.sort is using our compare to method.
Okay.
And so if I don't do this, we should get the unsorted student mug, the Friday crew, unknown mug, the Friday crew.
So how is array.sort working? Because isn't that like a normal method?
Yep. So array is a built-in class. Sort is one of its methods. And I was trying to demonstrate it earlier that inside of this method, it's going to call the compare to method in the class of coffee mug. Since my mugs is an array of coffee mugs, it's going to go to the coffee mug class and look at that compared to method to figure out what it means to sort coffee mugs.
But then you had to go and manually code what you would like it to.
Yeah, we had to kind of come in here and say, in this case, I want to sort it by the name. Before we were sorting it by the ounces.
So you're actually not calling compare to, you're just using sort to get to the compare to.
That's right.
Okay.
Yep, you're using sort to get to the compare to. Yep.
So in sort, it calls compare to,
And
then that's how you get to that one.
that is right.
That's cool.
That is right.
Are there, if we would use compare to in a different way and not use the array.sort, would we have to call compare to ourselves?
This is the only context I've used it in. Could you call it outside of that? So it is a public method. And so in theory, I guess I could come down, but again, so you could say student mug dot compare to stranger mug. And that's just going to compare these two objects against one another, greater than or less than. Of course, this compared to returns an int. So you're going to need to store that. Int is greater than equals. See what I'm saying? So now we've got this variable that holds a -1, a 1, or a 0, and it's going to compare them based on their names. Does that make sense?
Yeah, and then you can
So your question is, can you call that compare to method outside? Yeah, you sure can. Good question.
Well, whenever you call it, you have to student.mug or student.mug dot compare to.
Yeah, let's bring that back. Instance dot argument.
Because if you just do normal, you just write in compare to, then it's going to use the normal method.
Yeah, the compared to I'm using over here is the compared to that belongs to what is a string. So you can compare strings against each other. But remember, string's a built-in type, right? Coffee mug is not a built-in type. So we define, right, just how we're able to use compared to on strings because someone defined that. Like if someone were to use our coffee mug, they'd be able to compare coffee mugs against one another in that standardized way. All right. Last and not least, we're going to cover I Enumerable and I Enumerator. And for the demonstration of this, you've got the standard for loop, which we're using to iterate over an array of mugs. And you might all be familiar with the shorthand for each. Right? For each, this is the snippet for our for each. Now keep in mind this is this is the snippet. So we got the keyword var here, which again kind of handles the typing. But I'm going to change var to coffee mug. Var mug in my mugs. And label result.text is equal to mug.toString. So this is the shorthand version of this. And what are we sorting on lately? We're sorting on their name. And so we're going to do plus equals. Well, I'm going to pause the recording right here because I'm going to have to pick this up tomorrow because I'm confused. But that's okay. You don't need this for your lab. I will come back to this. I Enumerable versus I Enumerator. Full disclosure, I didn't expect that to work, and it did. So I got to figure out why. It's a good problem to have than the other way, right? But I'll pause the recording right here. We'll come back tomorrow.